Hello. Um, so this is my video for IA Week 8, and from this week, the videos that were posted primarily focused on um, agents, intelligent agents. So we kind of got into deep about what it means. Um, our first slide, or to introduce this topic, right? What are agents? And agents are just software program or systems that can perceive its environment and it can make decisions autonomously and take actions to achieve specific goals after learning and improving it performance over time, right? And they are a key component of artificial intelligence, right? AI, and can interact with their environment to gather information, process it, and then respond in a way that is designed to achieve a predefined object, right? And the images I have here are from Sakuna, who's using 10 shadows. And it's a good analogy in my opinion, because it's like you could see these things he summons are intelligent agents, right? They have a specific purpose, each of them, and they can act autonomously for a specific task, right? So, for example, the deer can heal him, and then Maharaga can just adapt to anything and so forth, right? Um, so some key attributes are like its perception. Intelligent agents use sensors to gather information about their environment, such as data, images, or even audio. Another key feature is decision making. They analyze perceived information and make decisions based on pre-programmed rules. Machine learning algorithms are a combination of both, right? Action, based on their decision, agents take actions to achieve their goals. This could involve interacting with the environment, other agents, or even other systems. And what I mean by environments, it depends on like the task or what you're doing. So, for example, email, right? The environment would be your email. Um, if you tell your agent to, let's say, like organize based on your most important emails, it'll call the necessary API to do so, right? And another key feature is learning. Many intelligent agents can learn from their experiences, improve their performance over time through a process like machine learning, right? And this proves just another point why I like this analogy I put up here because each of these shadows or monsters that you see on these screens can be um, fit in the definition and features of an intelligent agent. So going forward, what is the differences between traditional AI versus agent chatbots? Like, even I was confused about this very in the beginning. But just to give a brief overview, a traditional AI chatbot identifies user intent from questions like general queries in like ChatGPT. It uses systems like Claude, LLMs, and as I mentioned, ChatGPT to match intent. Even the wording varies from predefined examples. It just wants to extract, I guess, meaningful information, and it calls the appropriate code or API function from the database, right? And it can build frameworks like Dialogflow or LM-based frameworks. But this type of system does not use agents. So what does an AI agent chatbot do, right? It possesses all the same capabilities as your traditional AI bot, but it includes extra like features and capabilities. As I mentioned before, it's autonomous and it has certain decision making. It can learn from past customer interactions, such as ordering habits, and it has awareness about the environment, right? It checks whether, like for example, checking the weather or traffic conditions, and it provides suggestions, recommendations, or warning based on history and environmental context. An example is suggesting reordering a usual pizza, suggesting adding hot chocolate in a cold weather, or warning about delivery delays to snowstorm. So, what I have here, these two, another analogy is a regular NPC versus in Baldur's Gate their NPCs are very intelligent, right? They have specific rules compared to regular NPCs, right? And we could think of this analogy, right? Think of the low-level NPC, a non-playable character in a vast RPG world. It has very specific set of pre-programmed dialogues and responses to certain keywords or phrases, right? If you ask it something outside of its limited script, it's likely to give you a generic and unhelpful helpful reply, versus like Baldur's Gate, right? in this case, the intelligent agent chatbot. Think this more in a well-developed supporting character, even protagonists with evolving abilities. They can learn from interactions, understand context better, and adapt to their responses, right? They might even be able to take initiative and perform actions on your behalf, like scheduling something or finding information across different sources. Imagine it like your witty, resourceful sidekick. Um, in Baldur's Gate, uh, that not only answers like your questions, but also anticipates your need and helps you navigate complex situations. So on to the next slide. How does an intelligent agent work? Um, An intelligent agent works by, just simplifying an automatic complex task, right? Most autonomous agents follow specific workflow, then perform assigned task. So, like for the first idea is to determine goals, right? The AI agent receives specific instructions or goals from the user. It uses that goal to plan tasks that make the final outcome relevant and useful to the user. Then the next step is acquiring information. AI agents need information to act on tasks that they have planned successfully. Let's say, for example, the agent must extract conversation logs to analyze customer sentiments, right? As such, AI agents might access the internet to search for and retrieve information they need. In some applications, an intelligent agent can interact with other agents or machine models to access or exchange information, right? And we can kind of see this as like a real life Jarvis from Iron Man, right? The last thing is implementing tasks. With sufficient data, the AI agent um, I would say methodically can implement task at hand. Once it accomplishes these tasks, the agent removes it from the list and proceeds to the next one. In between task and completions, the agent evaluates if it has achieved a designated goal by seeking external feedback and inspecting its own logs. So autonomy with control, right? So just going more deep into agents, right? The defining characteristics of an AI agent is its autonomy, right, and independent thinking. This autonomy allows the agent to generate responses or take actions based on context, goals, and tool access, rather than following rigid, predefined scripts. However, there are limitations that are placed on the agent's autonomy from the developer, right? When building an AI agent, developers implement these controls to define boundaries of its autonomous actions. This is analogous or another analogy to having a dog on a leash. The dog, which is the agent, can roam around, be autonomous, but the leash control limits the area it can access, right? The agent is autonomous, but only within the parameters and controls set by the developer. So some tools is like LangChain. Uh, it's a framework for developing applications powered by large language models. And some core components of LangChain, right, is its prompt management, tools usage, and chaining agent decision logic, and React, which is reasoning and acting iteratively, right? Um, so why is it called LangChains? One of its features is called chains, which is a sequence of calls that goes from prompt to model to output. And there's different types such as simple chain, LM chain, and a sequential chain, right? And then another key feature is obviously agents. It uses tools to resolve problems autonomously. And this is where the React framework comes from, right? Not React, the front end mobile, but the reasoning and acting loop. Some other tools that help with developing agents are, uh, its memory to keep passive track of past interactions, and it's capable of observing user input, thinking step by step, and choosing tools to act on. So the one of the things I personally found important in agents is the emergence of model context protocol, right? And this was recently introduced, I believe, last year, right? Um, in an open standard, open source framework introduced by Anthropic, right? And Anthropic is basically a company that specializes in intelligent agents. Um, it was focused on developing safe and beneficial AI systems, and they're particularly through their unknown chatbot, which is Claude. They are known for the research into AI safety, interoperability, and ethical development of LLMs. Right. Um, so they're really focused on the aspect of ethical and trustworthy developments for agents. So um, MCP was designed to standardize context exchange between AI assistants and software environments. Um, Model Context Protocol provides a model agnostic universal interface for reading files, executing functions, and handling contextual prompts, right? The protocol just basically enables the developers to either expose their data through MCP servers or build AI applications, aka MCP clients that connect to these servers, right? On to the next slide. The protocol, some more just background information about this, excuse me, is that the protocol was announced in November 2024 as an open source standard for connecting AI assistants to systems or data libs, including content repositories, business management tools, and development environments. And this addresses the challenge of information silos and legacy systems that constrain even the most sophisticated AI models, right? Um, Anthropic introduced MCP to address the growing complexity of integrating LLMs with third party systems. Before MCP, developers often had to build custom connectors for each data source or tool, resulting in what Anthropic describes as an N times M data integration problem. MCP was, I would say, designed as a response to this challenge. It offers universal protocol for interfacing any AI system with any structured tool or data layer. This protocol was released with software development kits in multiple languages, including Python, TypeScript, Java, and C. Um, some more things that MCP can be applied across is software development. There are some IDEs such as Zed, platforms like Replit, and that use Model Context Protocol. Another way of applying MCP, right, is enterprise assistance. Companies like Block use MCP to allow internal assistants to retrieve information from proprietary documents. Natural language data access. Applications like A12 SQL leverage MCP to connect models like SQL databases, enabling plain language information retrieval, right? So it's just like basically the middleman. We're using natural language to do a command, right, instead of manually um, coding it ourselves. So for the natural language, instead of like doing a query, a SQL query, we can just use natural language to extract the information we want, and it therefore creates the query for us. On to the next slide. So the adoption of MCP was actually adopted by OpenAI recently, which is around March 2025, and they officially adopted it following the decision to integrate the standard across its product, which is pretty big, including the GPT desktop app. OpenAI CEO Sam Altman announced the move, emphasizing that MCP support would be available in OpenAI Agents SDK, with future support planned for ChatGPT. Um, Altman really described this adoption as a step towards standardizing the AI tool connectivity. Prior to OpenAI's adoption, the potential benefits of MCP has been discussed extensively. So by like adopting MCP, OpenAI joins the other organizations such as Block, Replit, and SourceGraph in incorporating the protocol into their platforms. The wide adoption just highlights MCP's potential to become a universal, open standard for AI system connectivity and interoperability. Um, so onto the next slide, I'll be talking about how the architecture of how MCP works, right? So as we know, it helps you build agents and complex workflows on top of LLMs, right? So the basis is using large language models, which just integrates tools and that MCP provides, right? A growing list of pre-built integration that an LLM can directly plug into. Um, so the general architecture at its core, MCP follows a client-server architecture where a host can connect to multiple servers, as we can see on the left, right? MCP clients, so it then goes to the clients, right, through its protocol. It maintains a one-to-one connection with its servers. And these servers are pretty lightweight programs that each expose specific capabilities through standardized MCP protocols. And then the local data sources, as you can see on the right, we have local data source A and local data source B. It contains computer files, databases, any services that the MCP servers can securely access. And then lastly, it's the remote services, external available over the internet that MCP servers can connect to. So generally what this is saying is like what we're doing is when we query something, for example, I want to organize my emails, it's going to go through the servers, call the necessary API, get the necessary data, manipulate it, and send it back, and so forth, right? So this is kind of like you can see it as an introduction to a real life Jarvis. And that concludes my presentation. Thank you so much.